In this video we will go over exercise D1 from the steel design examples according to the Canadian S1614 code, which is available for downloading at our website. Here is the exercise. We need to choose a 200mm W shape that will support a tensile dead load of 130 kN and a live load of 400 kN. The member will have a length of 7.5 meters. We will determine the member resistance under factor forces using the bolted end connection shown below and compare it to hand calculations. We will also verify if the member satisfies the maximum slenderness ratio. For this exercise we'll be using a W200 by 31 section from the Canadian Steel database. What I'm gonna do next is to take the force results from S-frame and use SPAT to code check this section. Let's open the S-frame file that I have. I already built this model in S-frame. So let's check some of the properties to make sure I'm compliant with the exercise specifications. If we right click the section properties, we can see that we have defined a 200 by 31 section from the Canadian Steel database. Here are the properties. For material, right click on the material tool. These are the material properties I'm using. The support conditions, as you can see, is pinned at the top, but it can move in the Z direction, fixed at the bottom. And if we switch to the loads window, you can see I've defined two load cases. And if I display my loads, you can see I have a axial load in tension for the dead load and a second load for the live load. I also define a load combination. If I go to edit load combinations, I can see I have 1.25 dead load plus 1.5 live load. Here they are. I already run an analysis, a linear static analysis for this model. And now I can check some of the results if I go to the graphical results window. We will focus on the axial force results for the load combination. So remember to click here and select your load combination. I go to the axial force diagram results. We see a maximum tension value of 762.5 kilonewtons. Remember that I don't have any other load cases in the other directions, and with this information I can go and open SPAT. Go and open SPAT. The first thing I'm going to check is that we have the correct design code. We go to Options, Design Code. I can select the design code we're using for this exercise right here and click OK. Then select our steel section by clicking here. But if you're not using the correct steel table, you can just go back, go to Options, Steel Table, and I'm gonna use one of the Canadian Steel tables, this one. And then I can go again, click here and search for that I-shaped section. Remember, we're using W200 by 31 right here. This is our section and I click OK. You can see it here. I will activate the load case I'm gonna use. Load case number 1 needs to be active, and this will be my load combination. You can change the subject here. Remember, it's 1.25 dead load plus 1.5 live load. Specify the parameters and demands for your section. We have an axial load of 762.5 kilonewtons. Remember, you can see the description for each header in Options, Descriptive Headers. You can see the full description. The section, as you remember, is 7.5 meters long, so I will specify that for these three fields. And this is important to consider the slenderness effects. Before running a code check, there's one more thing to determine. The exercise mentions the end connection is bolted. Hence, we need to specify the net area gross area ratio. And we can do so if we go to Edit, Constraints, here you specify the ratio. I will place 0.78 and click OK. And of course, remember, you can see the code you are using and the steel table at the bottom. To run a code check, we just go to Run, Code Check. Here's the SPath report, which will show automatically, showing the different clauses. We can increase the size if we go to View, Zoom by 200. Now we can better see this window, and we can start comparing our results. Here's the value for net area. According to our hand calculations is this value. And here are the values for the factor tensile resistance check. According to our hand calculations, by verifying the slenderness ratio, we can see this value is having a passing code check.